Hi, everyone. Let me adjust the mic. Is that better? Cool. So I'm super excited to be here today to present our group's work on scalable end-to-end ML platforms from AutoML to self-serve. This is also available via archive if you'd like to read the full paper. And shameless plug, my co-author, Igor Markov, is doing a talk tomorrow afternoon on generative AI that I'm sure will be excellent. Good idea. Thank you. All right. I think we're improved. So I'm going to go over why we should even care about the property of self-serve as it relates to ML platforms. I'll then do a little bit of discussion on the background and current landscape of ML platforms, and then I'll ground our conversation with two example platforms from our group. These platforms are Looper and Pex, which are currently deployed and being actively used across Meta. After that, I'll do a discussion on the 10 requirements that we think are important in order to achieve the self-serve quality, and 6 additional capabilities that could be critical depending on the use case. And then lastly, I'll do some discussion around some of the improvements we've seen and the deployment experience we've had with Looper and Pex, and then a general discussion on what it means to have an end-to-end ML platform that is self-serve. So why self-serve ML platforms? I think there's a few things that are really exciting and cool about self-serve ML platforms. The first being that you can see dramatic scaling of adoption of ML platforms when you enable the self-serve quality. So if you make it self-serve, both domain experts and novices are able to leverage these platforms, and then this allows the users to be able to explore maybe applications that were not previously explored due to bandwidth constraints or just like the number of experts you have available at your company. So by exploring these previously untapped applications, you can directly drive business value, and you also see a high reuse of ML capabilities and infrastructure with high client productivity. So it's really exciting to drive the adoption of both the platforms and also the increase in business value. We did a meta blog post on Looper and Pex in April of 2022 that we're pretty excited about that describe Looper and Pex as well. And obviously, developing these platforms is not trivial, right? You're going to need to have really heavy reliance on AutoML techniques. You're going to need to do platform integration. You're going to have to be able to validate and test your models and policies online. And so I'll dive into that a little bit more as the talk goes on. So, like I said, with self-serve, we're expanding the impact of ML. So the platform team has a shared engineering effort where we can develop new technologies, we can do the system maintenance, we can do system upgrades, and so the platform team takes care of a lot of this burden of ML lifecycle development so that customers are then able to focus purely on the application of their use case. So they don't have to think about the burden and maybe the tiresome tasks that come with ML development and deployment. So because the platform team is spending all this time developing their platform and upkeeping it, the impact of the platform is directly proportional to the economy of scale of usage of the platform, and we believe that achieving a self-serve platform allows for a really much more highly used platform, and so you're able to dramatically increase the impact. So let's take a step back and talk about the background and current landscape of ML platforms. I don't think anyone here is going to be surprised by this. People think AI and ML are important. They want to use them at their companies. And MIT Technology Review did a survey of about 600 companies and validated this assumption that I think is pretty shared across the room here. So they interviewed about 600 companies, and 75% of them said that they think that development and deployment of ML is the key aspect of their data enterprise strategy in the coming years. But they did share some concerns around how do we scale up the use of AI? How do we speed up the development? And how do we enable AI and ML to be used across a wide variety of applications, not necessarily just a narrow scope? And this is where we think these self-serve platforms come in handy. So when we think about how we've developed ML in the past, we have the Kaggle paradigm, where you hypertune and manually update and improve a model, and you may spend months just trying to get a 0.01% performance improvement. And I think these competitions are really exciting. Lots of really good architecture development and optimization algorithms have come out of them. But they kind of overlook the implementation and runtime trade-offs. And so that's where the field of ML ops came in, to consider both, the runtime and optimization trade-offs, as well as how the model performs. They need to be considered in tandem, especially in an industry application. So then you think about, okay, well, we want to develop an ML platform, and this is an automated workflow to train an ML model for some specific task, right? And so this could be ranking, prediction, et cetera. And these platforms have trade-offs. You have what the client wants versus the technology available. You have the software development of the platform versus the ML development of the models you use. You have the Kaggle fine-tuning versus automating and reducing the cognitive load. You have to be able to connect it all together. So there's a lot of considerations that come in with an ML platform. And then when you expand them to be end-to-end ML platforms, not only are you thinking about a singular ML task, but now you also have the data collection piece. You also have the model retraining piece. You have the testing online to evaluate your performance. And these platforms can be generalized or specialized, but they cover a much more broad scope than maybe a single ML platform when they become end-to-end. And so end-to-end ML platforms also need to have extensive use of AutoML frameworks. And AutoML frameworks are pretty pervasive across industry. We have, I've listed some of the ones available. One from Meta is AX, which does black box hyperparameter tuning using Bayesian optimization from the adaptive experimentation team. And within our AutoML and end-to-end self-serve platforms that we're advocating for, we do have an extensive use and reliance on AutoML frameworks. So now let's talk about Looper and PEX, our two example platforms from my group. So they're really widely used at Meta. We have hundreds of use cases created by about 100 product teams, many product teams having more than one use case because they've valued the use. We have 3 to 4 million AI outputs per second, and the company has been able to drive business value by leveraging Looper and PEX. So starting with Looper, Looper is a general purpose end-to-end ML platform. Like I said, they could be specialized or general. And Looper supports many different ML tasks because it's more general. So we have the unsupervised contextual bandit, reinforcement learning, tile decision making. We have regression, classification, et cetera. And our Looper customers need to have no ML experience. And so this means that novices and experts can leverage Looper, and they've been able to do so and drive the time to launch of a new ML use case from several months down to just a single month. We have a paper that dives into the details of the Looper system called Looper, an end-to-end ML platform for decision making, but this is kind of a high-level overview that I'll just kind of touch on. So we expose this client API, and this is what our platform customers are able to leverage. It's very simplified, and by directly leveraging the API, they get access to the feature extraction, they get access to online experimentation, they get access to our Canary system where we test and monitor and deploy new models to adapt for data drift, and it's config driven, so you can see the changes that have happened. And then I'll shift to talk about PEX, which is our specialized platform. So PEX is an end-to-end ML platform, just like Looper, but it has a specialized task where we're allowing customers to leverage heterogeneous treatment effects to optimally assign end meta users to the best treatment for them, as opposed to the best treatment on average. Assigning the best treatment on average is what you would do in like a typical A/B test experiment. And so this is a way for customers to be able to use HT meta learners and RL models without necessarily needing to understand the implementation and details of developing and deploying an HT meta learner. And we're able to also directly optimize for product metrics with PEX as opposed to ML metrics. PEX also has this feature of a decision policy on top of the meta learner or the RL policy, which we can test offline using counterfactual policy evaluation and online with Bayesian optimization using that AX tool I mentioned earlier. Just like Looper, PEX requires no ML experience. PEX also has its own paper if you want to read more about the details of it, but this kind of summarizes what I just described. On the left hand, you have a randomized experiment, which is like an A/B test. Users are randomly assigned to a treatment. You evaluate how the treatment's performed. Say treatment C did the best. Everyone now gets treatment C. On the other hand, with PEX, users are randomly assigned to a treatment, but you then use that data to train your HT meta learner or your RL model. You could then do some interpolation, you could distill it to a heuristic, but in the end you end up with a personalized policy that's either heuristic-based or model-based, and then users are assigned to the best treatment for them. So Looper and PEX both have full custody of data throughout the entire ML lifecycle. We don't require any ML experience from our customers, and they aren't required to do any ML coding. Both are config-driven, retain reproducible models, and we regularly retrain the models to keep the models fresh and adapt to data drift. And now we're going to use those when we talk about what we think are the 10 requirements for a self-serve ML platform. But first, I want to talk about data and product impact as it relates to self-servability, as many of our requirements are related to data and product impact. So data handling is kind of like a difficult and somewhat burdensome task as part of training an ML model, right? You have to pipe it, you have to do pre-processing, and so the platform should maintain full custody of the data from start to end in order to reduce any kind of human error and make it much more simplified for users. You also want to be able to understand the product impact and not just the ML performance. So often you're deploying an ML model in order to drive business value, and you want to actually be able to understand that. And so we think that doing observational interventional tasks to do evaluation and optimization of your product impact is important, and counterfactual policy evaluation and online experimentation are important ways of doing so. So the 10 requirements for self-serve. First, you want to have a low cognitive barrier to entry, right? So many folk, like I mentioned, we want to be able to serve both novices and domain experts, and having a low cognitive barrier to entry allows us to do so. You need to build a simple UI that abstracts away a lot of the complexities and the terminology specific to machine learning or data science. And then getting into that data, you want to have automated data collection for the reasons I outlined in the previous slide. This allows for reduction of error-prone tasks and is just much more simple for the users. With auto-config, you want to be able to do two types of auto-configuration here. The first is to automatically select the ML task or the model that is necessary to perform the best for the user's use case. And the second is to do like traditional auto-ML, so parameter search, network architecture, etc. You also want to keep in mind that product impact metrics for the reasons outlined in the previous slide with full tracking and optimization. And by having the implementation and deployment of counterfactual policy evaluation, you're able to prevent deploying policies that perform really badly offline so end users don't get negative experiences. You also want to have sufficient ML quality. If the models suck, no one's going to use your platform. So you want to be able to drive really good performing models without having a lot of engagement and manual configuration from the customer. Full management of hosting of not only the data, but also the model, while being conscious and aware of your resource utilization so that you can minimize that, as many folks have constraints there. And then towards the end of the ML lifecycle, you want to be able to adapt to data drift. That's your model retraining and your canary system. You want to have resilience to disruptions, not only of your system, but your system's probably going to depend on those other AutoML frameworks. So if any of those have issues, your system should still be resilient and robust. You want to have customer-facing monitoring in case there is an issue. Customers should be able to self-serve and root cause the error on their own. And then scalable internal platform maintenance is really important. The team should be able to not only maintain the platform, but have time to develop new technologies so that the platform can remain state-of-the-art for years to come. Okay, so that was a lot, but let's apply it to Looper and PEX, and maybe it'll make a little bit more cognitive sense. So the low barrier to entry with Looper, it's a general platform, so it has a broader UI because it has a more general purpose. Whereas PEX is a more specialized platform, so it has a more narrow UI, and so this is a way of reducing the cognitive load as much as you can, and that may be more feasible for more specialized platforms. Both generalized and specialized platforms want to track product metric impact and have that adaptation to data drift. And then the auto-config for PEX, it's really interesting because you have a fixed ML task, right, of leveraging these heterogeneous treatment effects, but you could select the HT meta learner or RL or a distilled policy, and so there is still that auto-selection happening. Further, we have 6 additional capabilities that we think could be requirements depending on the use case, but aren't requirements for all end-to-end self-serve ML platforms. The first is open architecture. This is pretty helpful for platforms that want to serve more advanced users, because users could then use just a piece of the end-to-end workflow or be able to pipe in their own model. You have customizations to common ML tasks in a specialized platform, reproducibility of models if it's important to be able to go back in time and validate your results, meta-learning, including transfer learning. So like I said, PEX uses HT meta-learner, so this is not really optional for PEX, but is in fact a requirement. And then interpretable ML and fairness in ML can be important depending on the application. So, like I said, for meta-learning and transfer learning for PEX, this is a requirement, whereas for Looper, the transfer learning may be interesting if the related apps or related use cases. Interpretable ML has also been something that's been really exciting for PEX users. So not only do we have feature importance analysis, but we also have user segmentation analysis to see how different segments of users respond to different treatments. And we're able to distill these models into heuristic policies, which allows for a lightweight deployment of a simple heuristic as opposed to a model-based method, which has been quite popular. So diving a little bit further into some of the improvements we've seen with PEX and Looper, as well as our deployment experience and learnings. So we have automated updates to our ML models and decision policies. And with this, we've seen over 2 weeks per use case of eng time being saved per validation experiment. And so this has been really helpful for our teams to get valuable engineering time back. We automate online experiments for retuning decision policies, and this, again, saves engineering time to set these up and validate them. And we increase client trust by having this, so they know that not only will they get that initial business value, but they'll get sustained business value over time. And then we've also been able to show that we deliver repeated product impact. So on top of the initial business value, sometimes we're able to deliver even more so. So an example use case is that we had a use case which prefetched certain content, and it was then given to device. And so they had launched a use case already, but we were able to retune their decision policy and see a 0.73% increase in their product impact without regressing any of their guardrail metrics, which were computational cost. We've also done some empirical validation of the PEX product. So we had one team that evaluated PEX versus hand tuning an ML model versus using an ML toolkit. And so they saw that PEX outperformed the toolkit both in the amount of engineering time required and in the metric performance. Whereas PEX did slightly worse than hand tuning an ML model as it relates to product metrics, but the time savings was so substantial that they were willing to heavily invest in PEX and onboard many use cases. It was 2 to 3 weeks of active eng time to use PEX as opposed to 6 months. We also had a customer survey where we validated this concept of reducing the cognitive load. So all customers were at least somewhat unfamiliar with ML and had a strong interest in self-servability of the platform. And they did highlight like, oh, I don't necessarily understand some of these terminologies. Can you like help reduce the cognitive load even further? And this drove us to include like an automated base set of features that were automatically included in all PEXs, because even like the concept of features was a little bit confusing for some customers. So diving into a little bit of discussion here, we have the trade-offs where if you have a very hyper-specialized application that requires really nitty-gritty hand tuning, a self-serve end-to-end ML platform may not be the best use case for them, because if a 0.1% increase in performance is actually quite substantial to the product and business value, this is a more top of the pyramid use case, and we're trying to maybe focus on the more breadth than the narrow. And then we also understand that seasoned ML engineers may benefit from the automation of these like boring and error-prone tasks like the data pre-processing and the data handling, but they may be a little bit uncomfortable with having less direct control than they're used to. And this is why one of our additional capabilities that we advocate for is this open architecture, where more seasoned ML engineers are able to dive more deeply into the platforms. Oh, we went the wrong way. And then lastly, just to summarize some of the benefits of end-to-end self-serve platforms. So we shift the focus from the performance of the model to the product metric importance and the performance of the use case in relation to the business value. We're able to democratize the use of ML techniques beyond ML experts, which can dramatically increase the number of applications that can leverage machine learning techniques. The impact of end-to-end ML platforms is directly related to the number of users, and so increasing the self-servability of these platforms directly can increase the adoption of them and thus increase the impact of them. And then with these platforms being widely used, any new additional technology or technique that's integrated into the platform can then be reaped, the benefits of that can be reaped by all of the customers, and so you're able to dramatically increase your investment of time by the platform team. Okay, I think I have some time for questions.
I've actually got a quick question. These are great platforms, but when it comes to all the data Meta has, and being that most of it's, per what you said, in tabular format, how do you go about identifying which relational tables are connected to one another and how for materializing features at such scale?
Yeah, that's a good question. So let me go back to the looper diagram here. So we support, there's a tool called Feature Store, which has been written about. It's a Meta AI AutoML platform, and it has all the different features, and it's really easy to use. So customers can just say like, oh, I want, X feature about a user, and then that's able to be digested with the client API, and that is supported in a UI format.
Awesome, thanks.
Thank you for the presentation. I really enjoyed it. Two questions, if I can, possibly. I'm interested in how Meta. Earlier in your presentation, you mentioned observational task and intervention task. What is Meta's thought process about, characterizing what those tasks might be in the typical use case, and how you've gone about in developing the platform for those tasks? And then also just any insights you can share about what the discovery process was like for coming up with those 10 requirements for the platform.
Yeah, totally. I'll start with the discovery requirements for the platforms. So these platforms, Looper and PEX, have both been developed and used for many years at Meta. And so we have increased the self-servability of them over time at the request of customers. So we did see that there was, a bottleneck in usage of the platforms without the self-servability. And so because, you're investing X number of engineers' time to develop these platforms, you want to have as many teams be able to use it as possible. But if it wasn't self-serve, we had to kind of do some hand-holding there, and that limited our impact across the company. And so implementing these 10 features was how, and we did a lot of, obviously, debate within ourselves on what counted in the 10 and what was an additional one. And a lot of it came down to is it applicable to both general and specialized platforms? So the 10 requirements we think are applicable to both, whereas the 6 may be more specialized for, such as PEX needing the HT meta-learners. And then the observational versus interventional tasks, I think this is kind of getting more at the being able to do the counterfactual policy evaluation where you can explore policies and model performance offline. So you want to go ahead and throw out any type of model or decision policy that's performing particularly poorly, so that end users don't get what we know is already a bad experience. And then also being able to watch the product impact online and then optimize for that. So with PEX, we're actually able to directly optimize for product impact as opposed to optimizing just on an ML loss function or something.
Thanks for the presentation. So you mentioned that this platform was built to empower people without any machine learning experience to use machine learning, right? But you work in Meta, and Meta also happens to be such a company where they have a huge pool of ML engineer. And the very seasoned ML engineers are embedded into almost every major product. So I'm wondering, what's your biggest challenge to demonstrate the value of such an auto ML platform in such a special environment? Thank you.
Yeah, I think that's a good question, and I think that actually kind of highlights the need for these self-serve ML platforms, right? Because you're right, we're very fortunate to have really excellent ML engineers, but even with the vast breadth and depth of the talent at Meta, there were still applications that were not being explored purely due to bandwidth of personnel. And so we were able to onboard product engineers and even PMs who could then bring this kind of tooling onto their team in a way that just wasn't being prioritized. Okay, any others?
Thanks, Mia. This has been amazing. I'm a novice in, ML ops, and so seeing that it can be self-serve is really cool. You talk about product impact. My question, if you're able to share, is: are companies, figuring out safety by design and product impact, meaning how to retain users and create trust with their users, or is it truly just based on revenue build?
Yeah, I think that's a really good question, and I think what we found is that different teams have different metrics that they define as product impact. So every team may have a different metric that it's goaling on. I can't necessarily go into which metric specifically, but it's not just revenue. There are different metrics, and engagement, things like that are important.
Thanks for sharing. What are kind of the ML concepts that are most valuable for the non-ML engineers that are using the system? Thanks.
Yeah, that's a good question. So really reducing this cognitive load is something our team has put a lot of effort into, but there are things that you just can't remove, right? So the features is something that we do rely on clients to provide, what features they think are important for their use case, because as a platform team, we don't have insight into that. And so for PEX, we developed that base set of features based on, features that have been important over, X number of use cases. But understanding features has still been kind of important, and we've worked really hard on developing documentation and, info videos that teams can use in order to get just a base level understanding. Maybe a 2-class intro to ML would be good. Yeah. Thank you all for all the really great questions. I appreciate it.
Thank you.